In this video, I'm going to explain the working of an solved example from textbook based on probability that uses the properties of set theory. So the question says that if ABC are three events associated with a random experiment, we need to prove that PA union B union C can be written as PA plus PB plus PC minus PA intersection B minus PA intersection C minus PA B intersection C plus intersection of A, B, and C. So for solving this question, we'll be using three properties of set probability. That is A intersection B intersection A intersection C can be written as intersection of A, B, C. We are also going to use this property that PA union B is PA plus PB minus PA intersection B. And also that A intersection, that is the distributive property, that is PA intersection B union C can be written as PA intersection B and union PA intersection C. So for solving this, the first thing that we do in this question is to replace this B union C with E. That's what I did. I replaced this B union C with E. Now, the LHS, which is PA union B union C, can now be written as PA union E. And after that, I'm going to apply this property, that is PA union B, which can be written as for this step, is PA plus PE minus PA intersection E. Now, one by one, we are going to replace this E with B and C. That is E back to B union C. That's what I did in the next step. I wrote E as B union C. Rest is as it is. That is PA plus PE minus PA intersection. In the next part, we are going to apply distributive property at this place. So if I apply distributive property, I'm applying distributive property. So A intersection B union C, that's from here, we can write P A intersection B union A intersection C. Now we'll mark this as equation 1 and we'll compare with the LHS, RHS. We'll see that we need A, which we already have. We need BC, we don't have. So therefore, what we are going to do is to change this into back to B and C. So marking this equation 1, what we are going to do is to replace this PE with PB union C, which can be written as PB plus PC minus PA intersection B. And over here, considering, let's say I do it in the next part. This I have going to solve here. So consider this to be, say, A and this to be B. So this is actually PA union B. So we are going to apply this relation, that is PA union B is PA plus PB minus PA intersection C. So that is P of first part, first element, P of second, and then the intersection of A and B, like that. After that, we'll keep this LHS as it is. And then we are going to apply this property over here, that is intersection of A, B intersection with A and C is same as PA intersection B intersection C. So this is what we have turned replaced E with A and B. And finally, placing these values or putting this second and third. The second is, this is the second and this being the third. If we replace this in the first, what we are going to get is PA union B is PA plus PB plus PC minus PB intersection C. And this, if I replace, we are going to get this. So on simplifying it, we'll get the RHS. So keeping in mind, if you remember the properties which we are going to apply here, the first thing that we have to remember that we have to replace this E first. We have to replace B union C with E. Once we are replaced it, what we are going to do next is that we are going to apply these three properties at different places. The first is replacing E with B union C and applying distributive property over here, replacing E with PB union C and applying this property of union of, that is PA plus PB minus PA intersection C. And then replacing PA intersection B intersection A intersection C with PA intersection B intersection C, and substituting the values of second in first and also third in first, and simplifying it, we get the RHS.